Hi guys, in this video I will cover the iterator design pattern. The purpose of this design pattern is to provide sequential access to values of an aggregate object without exposing its internal structure. Let's take a look at this UML diagram to better understand what that means. Here I have a class named myCollection. This has an array list of values as its internal member variable, and it has two methods. One method to get a value by index, which returns an integer, and a second method named size that returns the number of elements in this array list. Now I want to follow the iterator design pattern to provide a standard way of accessing these values without exposing its internal structure. Now, by using get with index, I somewhat expose it because accessing something by index is typically an array or array list. So I want to really completely abstract this. When I use the iterator design pattern, it gives me greater flexibility on the implementation. If I later need to change the array list to a set, and sets are typically unordered, the iterator design pattern would abstract any implementation details of this class. So it's easy to switch from array list to set or to anything else. So I can make modifications without touching any code that relies on it. So let's see how this works. The iterator design pattern has two interfaces. The first one is named iterable and the second one iterator. Let's first understand what iterable means. Iterable simply means that a collection can be iterated upon using an iterator. So for my class here, my collection, I implement iterable, and that means that anybody can use an iterator to iterate over the values of this collection. This interface has a single method named iterator that creates a new iterator object. Now let's take a look at the iterator interface. This interface defines two methods. The first one is named hasNext, which returns a boolean, and the second one is called next, which returns an integer. The idea is that hasNext checks if there's another element in the sequence. If that returns true, the next step is to call the next method. Next will return the next element in that sequence and move the pointer forward by one. With pointer, I mean simply a pointer in a sequence. It's not the implementation pointer. It's really just an index or pointer, or however you want to call it, that keeps track of the position in that sequence. So using an iterator always has the convention of calling hasNext and next in an alternating way. Again, I have a collection. I want to iterate over the collection. I call iterator, which returns a new iterator object. Then on that object, I call hasNext. If it's true, I call next. I call next as long as hasNext returns true. Once hasNext returns false, I reach the end of the sequence and I stop. Now let's dive into the code and see how this is implemented. Here I have the myCollection class that I just showed on the UML diagram. This class has an array list of integers. This member variable is named values. In the constructor, I can add one or multiple integers and add these to the values member variable. And then I have the two methods to get a value by index and to get the number of elements in this array list, or in other words, the size of that array list. Here you see the iterator class. I implement the iterator interface. Note that Java provides this in the java.util package. So it's java.util.iterator. It expects a generic argument of the elements. And in my case, the elements will be integers. So I use the generic argument for integer. And I implement this interface. Now, in the constructor of this iterator, I expect the collection. I assign the collection to the same name member variable, and I keep track of the index in that sequence. So initially this is 0. Then I override or implement these two methods of that interface. The first one is hasNext. hasNext simply checks if the current index is less than the size of that collection that I have. So initially it's 0. If there are 0 elements, it would return false. There's nothing to iterate over the collection. If the size is 1 or above, initially this would return true, because there's at least one element in that sequence. Then I also implement the next method. Next method gets the next element in the collection and increments index by 1. So I call collection.get with the current index, and then after I get it, I increment the index by 1. Let's say I have a collection of 3. Index initially is 0. 0 is less than 3. This would return true. Then the user of this iterator would call next. Next returns the element at index 0, increments index by 1. Then calling hasNext again. hasNext 1 is less than 3. Returns the element at index 1, increments index by 1. Index now is 2. 2 is less than 3. Calling next again and returning the element at index 2, increments index by 1, which is now 3. 3 is not less than 3, so this returns false. And the user of this iterator iterated over the entire sequence without exposing any details of the implementation. Now, how do I create the iterator? I want everybody to know that this collection can be iterated over using an iterator. So I implement the iterable interface. Again, it's generic, so I have to define the element type here, which are integers. And now what I'm saying by implementing this interface is this collection is iterable. An iterator can be used to access the values of this collection. This will require me to implement the methods. There's just a single method, like I mentioned before, which is called iterator. Iterator creates a new object of this iterator. So here I return new my iterator, and I pass in this object on which the iterator method is called. This will then call the constructor here, pass in the collection, assign it, initialize the index to 0, and the iterator can be used. Note also that iterable is also in the java.lang package. It's part of the JDK. Now let's see how we can use this. I have a main method, and I create a new object of my collection. I initialize this to a few values, 4, 13, 2, 9, and 6. And now I want to use an iterator. I define an instance of java.util.iterator, and I initialize this to call, which is my collection object that implements iterable, and that's why I have the iterator method. So again, if I go into this method, this is the method here I implemented by implementing the iterable interface. This will internally create a new iterator. Note that I have no idea about the actual class of the iterator. I'm really working with polymorphism by just declaring an interface. So I hide the implementation of the iterator, and I hide the implementation of the actual data structure that is used to store these values. Now I can use the iterator by calling while hasNext. I call iter.next to get the new value and move the iterator one step forward. And here I output the value. And that is it. So when I run this, I here get the values 4, 13, 2, 9, and 6. Note that I never exposed any implementation details of my collection. and I did not even expose the class that implements the Iterator interface. All I worked with is interfaces. So here Iterator returns an object, some iterator that implements the Iterator interface, and then I call hasNext and next. HasNext checks, is there another element? If that is true, I call the next method, return that element, and advance the iterator by 1. I output it and call hasNext again. Eventually, when I reach the end, hasNext returns false, and the loop stops. Note that there's another really nice way of using an iterator. That is using the for each loop. Now I can call for integer value of this collection. Basically, for every value in my collection, I want to perform some action. And here what I want to do is I want to output it. This is a very clean way of writing it and using iterators. It uses the iterators underneath the hood without exposing anything. Now if I run this, you will see the output twice. So I add a line break here. Now when I run this, you see the output twice. The first one is using the iterator explicitly, and the second time was using the iterator implicitly with a for each loop. I hope you enjoyed this video. Thank you for watching.